Okay. Today we're going to be looking at the mutually exclusive and overlapping classwork. And use this if you are confused on any of the questions. You can also just go look at my answer key if you just want to check your answers. The first 5 questions are just you determining, if the following events are mutually exclusive or overlapping. So let's run through this real quick. If we are rolling a die, this should say 6-sided die. What is the probability that the number is greater than 3? And then the second event is, what is the probability that the number is even? So can both of these events happen at the same time? Absolutely. You could roll a 4 or a 6. Those are numbers that are greater than 3 and are even. So this is overlapping. Let's see here. You're picking somebody. It looks like you're picking somebody randomly at your school. What is the probability that the person is a senior? What is the probability that the person is a junior? These should be mutually exclusive. I know technically we have some folks who maybe should be seniors and are juniors, but you're either one or the other. You're either a junior or you're a senior. You can't be both. All right, so now number 3, the experiment of answering multiple choice questions. What is the probability that you choose the correct answer? What is the probability that you choose answer A? Well, this is overlapping. You could have a correct answer that is answer A. So this is overlapping. I'm just going to write over. You're selecting a candy bar. What is the probability? I guess you're randomly selecting a candy bar. And what is the probability that this candy bar has nuts? What is the probability that it has caramel? I guess we have to know a little bit about candy bars to answer this question. I think this is overlapping. Isn't there a candy bar like Baby Ruth or something? That has nuts and caramel. So that would be overlapping. It's possible to pick a candy bar that has both of these things. And then this last question, I know some of us aren't great with cards. If you pick a card randomly from a deck of 52 cards, what is the probability that it is a jack or a spade? Is it possible to have a card that is both a jack and a spade? Absolutely, there is a jack of spades. So this is overlapping. This is not mutually exclusive. So basically, guys, if you're still sort of struggling with this, just know, like if you have 2 possible events and it's possible for both events to be true with picking sort of one thing, that's overlapping. If it's not possible for both events to be true picking one thing, then it's mutually exclusive, like it was in number 2. We couldn't pick somebody that was both a senior and a junior in high school. All right, so let's get to some actual math work here. Find the probability of each happening if you roll a 6-sided die. You roll a 3 or an even number. Let's see here. If we roll a 3 or an even number, we're going to use that probability formula, the probability of rolling a 3 plus the probability of rolling an even number. And then we want to subtract out the probability of both occurring at the same time, 3 and an even number. Well, I think these are mutually exclusive. If I have a 6-sided die, my probability of rolling a 3 is a 1 out of 6 chance. My probability of rolling an even number is a 3 out of 6 chance. What is my probability of rolling a 3 and an even number? Well, 3 is not even. So there is no number we could roll on this die and have it both be a 3 and an even number. So we have a 0 out of 6 chance here. So these are mutually exclusive. This is going to end up being 0. 1 plus 3 is 4. 4 minus 0 is 4. So it's just 4 over 6. We didn't really need this overlapping part because they did not overlap. All right, what is the probability that you roll a prime number or an even number? All right, so I wrote out the prime numbers here. If you didn't know what prime numbers are, in the first 6 numbers, 1, 2, 3, and 5 are our prime numbers. Actually, is 1 a prime number? Oh, man, I don't know. We're going to say it's a prime number. I feel like it's not now. Oh, well. So we're going to say 1 is a prime number, though. So we have 4 prime numbers. And what is the probability that we roll a prime number or an even number? All right, so probability of a prime plus our probability of an even number minus the probability of a prime and an even number. All right, so all the numbers on our die are 1, 2, 3, 4, 5, and 6. What is the probability of rolling a prime? It really should be 3 out of 6, but I put 1 right here, so we're going to say 4 out of 6. We have 4 numbers that I'm telling you are prime, even though one's technically not a prime number. And then what is the probability of rolling an even number? We have 2, 4, and 6. Those are our 3 even numbers we can roll. So we have a 3 out of 6 chance of rolling an even number. And then we want to subtract out the probability of rolling a prime and even number. So how many prime numbers are also even numbers? It looks like just the 2 is going to be our even number that is also a prime number. So we have a 1 out of 6 chance for that. And so if we work this out now, 4 plus 3 is 6, and 6 minus 1 is 6. We get a 6 out of 6. So that's 1 or 100% chance of either rolling a prime number or an even number. All right, last question here on this page. You roll a number greater than 3 or an even number. All right, so what is the probability of it being greater than 3? So a number greater than 3 plus the probability of an even number. And then we want to subtract out the probability of pulling a number that's greater than 3 and even. So my probability of picking a number that's greater than 3, well, 1, 2, 3, 4, 5, 6. There are 3 numbers that are greater than 3, so we have a 3 out of 6 chance of doing that. What is the probability of drawing an even number? We have 1, 2, 3 even numbers, so 3 out of 6 chance for that. And what is the probability of pulling a number that is greater than 3 and also even? Well, 4 and 6 are both greater than 3 and even, so we have a 2 out of 6 chance of pulling that. We want to work this out. 3 plus 3 minus 2 is going to be 4. We have a 4 out of 6 chance of pulling a number that's greater than 3 or an even number. All right, if you flip over, let's see here. We got a Venn diagram. Doesn't give us any context, so we're just finding the probability of A. We've sort of done these already before, so this is kind of review for our Venn diagram. We want to first count up how many people do we have, or how many things do we have in this Venn diagram. So we have 19 plus 12 plus 59 plus 10 people or items, whatever this Venn diagram is representing. And if we add these up, should have done this ahead of time, 19 plus 12 plus 59 plus 10, a nice even 100 items. So what is the probability of choosing A? Probability of choosing something that's in A, well, there are 19 things that are only in A, and then there are 12 things that are in A and B. So we want to add 19 and 12 together. That's going to be a 31 out of 100 chance. What is the probability of choosing something that's not in B? So this is the complement. It means find the probability of something not in B. So here's B. There are 71 things in B, and there are 19 plus 10 things not in B. So we want to add 19 and 10 together. We're going to get 29 out of 100. That is our chances of picking something that's not in B, because there are 19 things here that are not in B, and there are 10 things here that are not in B. We have a union. All right, so what is the probability of choosing something in A or something in B? So they don't have to both occur at the same time. As we want to count everything up that's in A and also everything up that's in B, and sort of see what we get. And if I work this out, so my stuff in A is 19, my stuff in B is 59, and then we have 12 in both. So we want to add 19, 12, and 59 together and sort of see what we get. And it looks like we're going to get 90. And so we have a 90 out of 100 chance of picking something in A or B. And then finally, what is the probability of choosing something in A and B? So how many things can we choose that are both in A and in B? We can see pretty easily it's going to be 12 out of 100. There are 12 things that are both in A and B. All right. And last one, we have to make our own Venn diagram. When you arrive home today, you find 27 cupcakes on a large circular plate. 13 have icing, 11 have sprinkles, and 4 have both. Label the Venn diagram to help you answer your question. I will represent the icing cupcakes. S will represent the sprinkles cupcakes. All right, we have 4 cupcakes that have both icing and sprinkles, so we have 4 right here in the middle. All right, so if we have 13 that have icing, and we're already accounting for 4 right here, that have icing, but this has icing and sprinkles. 13 minus 4 is 9. We have 9 cupcakes left that only have icing. So we have 9 that have only icing, 4 that have icing and sprinkles. So that makes 13 total that have icing. We want to do the same thing for the sprinkles. We have 11 total. We already have 4 right here, so this is going to be 7. 11 minus 4 is 7, and that's how many just have sprinkles. There are still 11 total that have sprinkles, but 4 of those have sprinkles and icing. What's the number that's going to go out here? Well, we had 27 cupcakes total, and we're already accounting for 9, 4, and 7 of them. So we want to subtract out 9, 4, and 7 from this to see how many we have left. And I think I'm going to get 7 right here. So there are 7 cupcakes that neither have icing or sprinkles. And what kind of cupcake does not have icing? This is ridiculous. All right, what is the probability of choosing a cupcake with icing? Well, 13 have icing. It says it in the problem. We can also see it on the Venn diagram that there are 9 plus 4, so 13 that have icing. So we have a 13 out of 27 chance of picking a cupcake with icing. What is the probability of choosing a cupcake with sprinkles? Well, it says it in the problem, 11 have sprinkles, but we can also see in our Venn diagram, 4 plus 7 is 11. We have 11 out of 27 chance of choosing a cupcake with sprinkles. What is the union of choosing a cupcake that either has icing or sprinkles? So it doesn't have to have both. It like just how many cupcakes both have icing or sprinkles. Well, we want to add up 9, 4, and 7. All right, because these are all the cupcakes that have icing or sprinkles or both. It's okay to have both within union. So 9 plus 4 plus 7. Looks like we're going to have 20 out of 27 cupcakes that have both. Or, sorry, that have one or the other or both. And then finally, the and question. What is the probability of choosing a cupcake with icing and sprinkles? So it has to have both of these things. There are 4 cupcakes out of the 27 that have both icing and sprinkles. Okay. Hopefully, if you had any questions on the homework, classwork, this helped you. If you have any additional questions, please email me and ask.